All right, we're going to go ahead and start on Unit 10, Part 2. I would like you right now, with your team, to go ahead and do problems 1 through 4, and then come back and we'll talk about them. So go ahead and pause the video, do 1 through 4, and come on back. All right, hopefully, for number 1, you remembered that a diameter and a tangent line always intersect perpendicularly. So we know that we always get, whenever we have in a circle a diameter and a tangent line, we know we always get 90-degree angles. Now it asks, how is that related to its intercepted arc? Well, the intercepted arc, if you have a diameter, would have to be a 180-degree arc. So we know that the arc is 2 times the angle, because the angle was 90. All right, so that kind of goes into number 2. Going to number 3, we have, using that same idea, what do we think is going on here? Well, we know that we have a 90-degree angle, so that means that this also has to be 90. And if this is 60 right here, we know its inscribed angle measure is 30, or half of it. So then I know that the measure of angle BAE has to equal 60, because that would be complementary with the 30. All right, so the question was, how is this related to arc BA? Well, maybe you're going, I don't know what arc BA is, but we know that this right here is a semicircle, so I know it's 180 degrees, and if 60 is already taken, then I have 120 left for arc BA. Now I want you to notice that the measure of AEB is 60, the measure of its intercepted arc happens to be 120. So we have a new theorem that if you have any chord now, not just a diameter or a radius, any chord touching a tangent line at the point of tangency, then the angle made between the two is going to be half of that intercepted arc, that arc that goes with the chord. This is very similar to our inscribed angle theorem as well, so it all kind of fits and goes together. All right, I'm going to ask you to go ahead and please do number 5, which is add this theorem to your blue book. And then I'm going to ask you with your teams to do numbers 6 through 8. Pause the video, do numbers 6 through 8, and come back and we'll go through them. All right, go ahead and pause the video. All right, we learned that when an angle is inside the circle. So for instance, like angle E here, I'm going to put a 1 and a 2. I want you to notice that angles 1 and 2 have to be congruent, because angle 1 and 2 are vertical angles. Now, when we put those inside the circle, we knew when it was a central angle, it equaled its arc. So just looking at this, here would be angle 1, and this is its intercepting arc AB. And then angle 2 is intercepting arc CD. Just looking at those arcs, if I would draw the central angles to those arcs, it's very obvious that the central angle to arc CD is much bigger than the central angle to arc AB. So therefore, arc AB has to be less than arc CD. Yet, they have this angle. They share this angle. So let's go back to this here. We have this angle right here, where I had my 1 and my 2. And who should get it? So like if arc AB was 60 degrees and arc CD was 100 degrees, well then if we went with what we were doing, angle 2 would be 100 and angle 1 would be 60. But those have to agree. They have to be equal because they're vertical angles. So the question is, how could we be fair? And this is going on to number 7 and 8. So how could we be fair? What could we do? And I'm hoping that you guys came up with, well, we could average those two. So if I would just average the two, that would split it fairly, and I would get that angle there is 80 degrees. Angle 1 and angle 2. That would be right in the middle of those. All right, so going to number 9, we have this new theorem. And it just says that if we have an angle in a circle that is not a central angle, because we already know what happens with the central angle. So if we have angles that are not central angles, then we just take the two arcs that the chords are intercepting and average them. And that's going to get me this angle right in here and this angle right in here. All right, I would like you again with your teams just to think about number 10. Yes, there are several questions. They are not rhetorical. I'd like you to think about each scenario and what it might look like. So take a moment with your team to discuss it. Go ahead and pause the video and come back when you're done. All right, so looking at this, we have some different scenarios. It says, what if we have two secant lines? So if I have two secant lines, so here's a circle. And if I have two secant lines, it asks how many arcs do we intercept? Well, I see two arcs being intercepted. I see an outside arc, and I see this inside arc. So arc A and arc B. And they have a relationship to this angle down here. Now before, on number 9, we averaged the arcs. In this case, we actually subtract them. So we have A minus B divided by 2. So instead of adding them and dividing by 2, we subtract their distance and divide by 2. And that would give me the measure of angle P, if I put a P here. So when you have two secants going through a circle like that, the angle made at the intersection of the two secants happens to be the outside intercepted arc minus the inside intercepted arc divided by 2. And now we have another scenario. What happens if we have a secant and a tangent line who intersect outside of the circle? Well, a similar thing happens. I want you to see that there's an outside arc here and there's an inside arc here. So we still have arc A, arc B, angle P, and this theorem holds true. So we would just subtract the two arcs and divide by 2. Now we have a third scenario, and that scenario would be if we have two tangent lines. So if we have two tangent lines intersecting a circle, or to the same circle, if you notice, when I use the two arcs, the outside arc minus the inside arc actually happens to be the entire circle. Like when you have two tangents, you end up with the full 360 degrees between the two of them. All right, I'm going to ask you guys to go ahead and pause the video. Write this theorem down in your blue book. It's on number 11 if you want the verbal description of it. Then I'm going to ask you to try number 12 with your teammates. And come back to the video. I'll give some helps as you go, but try number 12. I'll be around to help as well. And come back and check it once you have it done. Just go ahead and pause the video. All right, on A, I see that I have this intercepted arc and I have this intercepted arc, which go with this angle and this angle. And I don't have those angles and I don't have one of the arcs. But I see, I'm going to go ahead and erase that I just put on there. I do see, though, that with the 102, I have a supplementary angle there because that's on a line. So I have a supplementary angle of 102, which means if I take 180 minus 102, I end up getting the angle that I'm looking for to go with y. So this angle right here is going to be 78 degrees. All right, I also know this angle is also 78 degrees. Now, our theorem says that if I average the two arcs, I will get the angle. So I notice my two arcs are y and 95. If I average those, I will get 78. All right, so now we just need to solve this and get our answer. And we get y equal to y plus 95 equals 156. And then I go ahead and subtract the 95, and I will end up getting 61 degrees. So y would be 61 degrees. All right, on B, I see that this is a secant and a secant. So I know that my rule is I take the two arcs and subtract them, divide by 2, and that will equal the angle. Well, my two arcs happen to be A is my outside arc, 44 is my inside arc, and I know the angle. And if you're not seeing that, let me show you. So the two secant lines are intercepting this arc right here, which is an unknown, this arc right here, which we know is 44, and we know the difference of those divided by 2 would be the outside angle. All right, so I'm going to go ahead and solve this, and I would get A minus 44 is going to equal 60. So if I go ahead and add 44 to both sides, I get 104. So the arc at A is going to be 104 degrees. All right, let's go to number C, or letter C. On letter C, I see two tangents. So I know it's going to be the same as what I did on B. It's going to be A minus B over 2 will equal the angle. Well, you might be going, but I only see one arc because we have the outside arc, right? We have the 247. But wouldn't the inside arc just be the rest of what it takes to make a circle? So if I take 360 minus 247, I'm going to get 113. All right, so now we just use our new rule, which is 247 minus 113 divided by 2. And that's going to get me my angle. And that just comes down to 134 divided by 2, which is going to equal 67 degrees. All right, our last one. I see that this is a tangent line intersecting with a chord. So here's the chord. That would mean this is the arc being intercepted. And here's the tangent line. So I know this angle here is half of this intercepted arc. But then I'm like, okay, what is that arc? Well, if this line, this is a linear line, we know that it's a linear pair right here. Go ahead and erase that. So I have this linear pair right here. So I asked myself, what do I add to 125 to get to 180? And it's going to be 55. So I know this angle right here is 55 degrees. And since it's half of its arc, I know that x is going to be 110. All right, for your homework, I'm going to ask that you guys try number 13. There's a lot going on with that one, so give it your best. Give it a try and we'll go over it.